In y equals, we have to put in two functions, actually three. The third function would be x. And the first function was parentheses x plus 3. And it was cubed. And then we said minus 2. And the other one was the cube root. And this is x plus 2. And the cube root for me is 1/3. You can use other methods if you like. And then minus 3. I will use the standard viewing window, and let's see what happens. So this we know. Yeah, so they don't touch. They only cross the y equals x here, and they don't touch. They come close to y equals x. My marker is kind of thick, and I accidentally touched it, but I didn't expect it to touch. But of course, when one function crosses y equals x, the other one must. Because that's, all these points are the same, right? 1, 1, 2, 2, 3, 3, 4, 4. So if this is a point where the function crosses y equals x, that must be the same point where the inverse function crosses the same y equals x. Good. Any questions on finding the inverse? Any questions? Okay, let's move on to the next topic. So let's say, help me create a problem now. So in 2010, let's say somebody had $100,000 in a checking account. Let's suppose in 2020, or let's say 16 since it passed, so let's stick with the past so far. That person, let's say, in an investment account, let's say that person has only 80,000. Something happened, the stock market crashed or something. So we're asked to find a linear function, that fits the info. And then we are going to add 2 more questions to it. Okay. So what are we given in this problem? Perfect. Of course, I cannot write, so this is the time of the investment. So this must be t equals 0 or x, it doesn't matter. And then this must be t equals 6. So the ordered pairs will be 0, 100,000, and 6 and 80. Excellent. Perfect. So now, notice that this point is the y-intercept. I don't have to use y after I find the slope. I don't have to use y minus y1 equals the slope times x minus x1 because this is the y-intercept. So I can use the easiest of the 2. So first I have to find the slope. And what is the slope? You expect the slope to be a positive number or a negative number? Negative. Correct. So then you will say 80,000 minus 100,000 divided by 6 minus 0. So this is negative 20,000 divided by 6. And simplify it as negative 10,000 divided by 3. Please remember measurement unit. It means nothing without a measurement unit. What is the measurement unit for this? It's a rate of change, right? So it has 2 measurement units, one coming from the top and one coming from the denominator. Dollars per year. Very good. Which means it's his investment per investment goes down by roughly $3,000. Roughly. Maybe more than 3,000. Okay. Now we're trying to find the equation. So we will be using y equals mx plus b. Why? Because I have b. So that would be y equals negative 10,000 divided by 3x and plus 100,000. Assuming that the trend continues, how much money is left in this investment in 2019? So the trend continues. Find the amount in 2019. In our scenario represents t equals 9. So all you have to find is y equals negative 10,000, 100,000, sorry. No, it was 10,000, sorry. Times 9 plus 100,000. So I'll simplify. So this is 100,000 minus 30,000. So y will be 70,000 in dollars in 2019. If the person is not paying attention, let's say, to his or her investments, and never addresses, never takes the money out or reinvests it, how long will it take till 0 is left in the account?
We have to find y is 0.
Very good. Well done. So this will be 10,000 divided by 3x equals 100,000. What I would like to do is cross these 4 out. So then x is 30 years. Which means the year, in the year 2030, if this person is not addressing the issue and assuming the trend continues.
It'll be 2040 because we started in 2010.
Oh, it was in 2010. Sorry. Then in 2040, he or she will have nothing left. We graphed a polynomial function. We looked at a rational inequality. Are we okay with graphing another polynomial? Are we okay with graphing another quadratic function? Finding max min? Which one? Yes, which one? Polynomial? Okay, very good. What degree polynomial we want to look at? Degree 4? Everything okay? No, I divided both sides by 10,000. So we want polynomial degree 4? Okay, so make one up. Negative 2x squared. X plus 3. X minus? 1 it is. Is this polynomial, does this polynomial have degree 4?
No.
Yeah, 2 and 1 and 1. Degree 4. Very good. Let's start with the domain. What is its domain? All real numbers. Polynomials are defined everywhere. They are friendly functions. No restrictions, no headache. Very good. What is the end behavior? Since you already told me degree 4, so degree 4, how many maximum possible possible, maximum possible number of turns. 3 max turns. Okay. How many solutions? How many x-intercepts? Absolutely 4. So please give me 4 x-intercepts. 2 of them are 0. Very good. And x equals 1. Multiplicity
2, 1, 1.
is 2 plus 1 plus 1, 4.
Yes.
Excellent. And behavior. Remember, it's degree 4, and it behaves like x squared. Either this or this. This or this. Leading coefficient is? Leading coefficient is?
So it's
Very good. So 0, 0, -3, 0, 1, 0. What do I write for m multiplicity 2? What is this? Very good. What is this and this?
Cross.
Regular cross. I love it when my students study. It makes my life so much easier. Very good. That's it. We're done. Yeah, I have to write symmetry. F of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. I'm fine with that. Good. Does this function has asymptotes? Of course not. Only rational functions have asymptotes. So I'm kindly begging you, do not show any asymptotes on polynomial functions, because I've seen it. Yes, please. So asymptotes exist only for rational functions that we looked at. There are other asymptotes. There are other things for later. Yes?
I was going to say, so if we probably didn't have a negative a value, would the end behaviors be just positive, would it be positive instead?
Yes, because the degree is even. Very good. So let's graph. We start with the points, of course. -3, 0, 0, 0, and 1, 0. So let's look at this. Let's look at this together and try to figure out what's happening here before we graph it. It's coming from -infinity. We will normally cross at -3, 0. It has to turn because it comes back to the origin to turn again. It goes up, it turns because it has to cross at 1, 0 going to positive. I made an error there. Sorry. I said negative by negative, but I wrote positive. So one more time. From -infinity crossing at -3, 0 has to turn, comes back at 0, 0 to turn again, and crossing normally at 3 at 1, 0. We have no secrets other than max min. We can determine that. So this is definitely a turn. It has to turn again. It comes down and crossing at 1, 0. So this is the function you gave me, -2x squared, x plus 3, x minus 1. Yes, I don't know this. You have to wait till calculus and you'll determine those by hand with no huge effort at all. So in y equals, clear everything else. So we have -2 x squared in parentheses x plus 3 close x minus 1. Okay? So I see the action happens really between -5 and 5, so I'm going to adjust the viewing window. -5 to 5. Questions, please. And I don't really care for the negative part. -3 is good enough, but you see it's way up there. So y maximum, I'm going to say 40 with a scale of 5. No news, none whatsoever. It's coming, it crosses at negative 3, 0. It has to have a turn. See how it turns here? It has to, goes to a maximum, tiny maximum, but still maximum, and then crossing at 1, 0, going to negative infinity. So I will determine these two max between negative 3 and 0. So second and calc. And I want to find the maximum, which is 4, between negative 3 and 0. And that is, and I'll put it in the table, negative 2.2,
So
comma, 24.8. Yes.
when it comes to finding or determining the end behavior, just looking at the function, that is determined by the degree as well as the
The
leading
degree and
coefficient.
the leading coefficient, yes. Because if the degree is positive, if the degree is odd,
Yes.
if the degree is odd and the leading coefficient is positive, if the degree is odd and the leading coefficient is negative, if the degree is even and the leading coefficient is positive, and the degree is even and exactly. I need to determine the other one between 0 and 1, so another max. So another max, which is 4, between 0 and 1. And it gives us a max at 0.7, comma 1.1. So these are two local max. Well, actually, this one is absolute max as well. So I'll put them in the table at this negative 2.2, 24.8, local max, and also absolute. And this one is at 0.7, 1.1. So this is also local max. Okay. What about quadratic functions? Are we okay? I mean, we should have no difficulties with quadratic functions, graphing them. I will list what I expect. Shape, vertex, axis of symmetry, max min, x-intercepts if they exist, the y-intercept, domain, range. Those will be listed for you.
Could you just go over one?
Yes. So can anyone give us a quadratic function?
We need quantity 3x minus 7
Say it again.
squared.
So 3x minus,
7 quantity squared.
oh, okay. Very good. Because the leading coefficient is inside here, we have to expand the function. We cannot identify the vertex from this form. So, how many terms will you give when you expand a binomial? How many? Very good. First term squared. Minus 2 times the first times the second, plus the second term squared. Number 1 is the shape. Minimum or maximum? Yes. You know it's a minimum because the leading coefficient is positive and it has to come from positive infinity to positive infinity. Now we know that, right? Very good. Number 2, the vertex. How do I find the x-coordinate of the vertex? Very good, awesome. Negative b over 2a. Negative b in this case is, be careful, negative 42. 2 times a is 18. So this is 42 over 18. And I can simplify and get 21 over 9. Wonderful example. Thank you very much. See how I graph, how I plot 21. Oh, I'm kidding. How do I determine the y-coordinate of the vertex? Excellent. So f of 21 over 9. I prefer this one now. So 3 times 21 over 9 minus 7, everything squared, because this is compact. This is much easier now. Okay, so 21 divided by 7. Wow, look at that. 0. Well done. Which we knew. Very good. It's a good one. It's a very good one. We haven't seen something similar. Very good. Number 3, X-intercept. It is the vertex, of course. The only one is 29 over 9 comma 0. 29 over 9 comma 0. Oh, I should simplify it actually by 3. 7/3. So it's 7/3 comma 0. Good. Perfect. Number 4, Y-intercept. Y-intercept is when x is
44.
very good. Yes. So 0 minus 7 is -7. -7 squared is indeed 49. Very good.
Why did you put the X into 7 numbers?
Because it has an opening upward and the vertex is on the origin. Oh, on the y-axis. It's on the x-axis. So the y-intercept. So now 5, 6, and 7 are just words. Axis of symmetry. No, just x equals 7/3. Does this function have a max or a min? We already know it has a min. What is the min value?
Vertex.
Which is 0. Very good. So what is the range then?
0.
Very good. So here's the graph. So this is 2 and a little bit. And then 49, I'm going to say this is 49. It's not 49. Don't forget the axis of symmetry. So x equals 7/3. And here's the graph. Make it as symmetric as possible and not too acute at the origin. So this is f of x equals 3x minus 7, everything squared. Let's construct a polynomial now. Any questions on this? Any questions? Okay, let's construct a polynomial. Let's say degree 5 with the following solutions. X equals 0 with multiplicity 3. X equals 4, multiplicity 1. And x equals -1, multiplicity 1. It also passes through, say it again, baby, go ahead. Yes, we're constructing a polynomial with degree 5 with solutions x equals 0 3 times, 4 once, and -1 once. And let's say passing to the point 1, 2. Can anyone tell us how to write this polynomial? What is the starting point here? Very good. P of x equals. Yes, awesome.
X cubed.
Very good.
X minus 4. And then x plus 2.
Great job. So first I'm going to multiply these two. So P of x is a, x cubed. I really don't need parentheses around x cubed. And when I multiply these two, I get x squared plus x minus 4x, which is -3x and minus 4. Now I will distribute x cubed, only x cubed. And at this point, I will use the pointer that I was given, 1, 2, to determine what? What am I missing here? The leading coefficient. Great job. Good. So, how do I use 1, 2? What do I have to write?
P1
Very good, awesome. P of 1 equals 2. So when I plug in 1, 1, negative 3, negative 4. So A multiplied by negative 6 is 2. Do you agree with this statement? 1 minus 3 is negative 2. Negative 2 minus 4 is negative 6. So A times negative 6 is 2. Would you agree? So P of 1, 1, 1, 1. 1 minus 3 minus 4 is negative 6. And I copied A. Are you with me, everyone? Is this okay? So then A equals negative 1/3. So here's our polynomial. P of x, negative 1/3, x to the 5th, plus x to the 4th, plus 4/3 x cubed. And this is the only polynomial that fulfills the given conditions. It passes through 1, 2, and it has the given solutions. 3 of them are 0. 1 of them is 1. One of them is negative 1, and the other one 4. Yes, please, Connor.
So where did we get the negative 6 again?
So the point, every time I'm given a point, I'm really told when x is 1, the function value is 2.
Okay.
So then P of 1 is 2. So when I plug in 1, 1, 1, 1, 1 minus 3 minus 4 is negative 6.
Oh.
That's the only equation that allows us to determine the leading coefficient. I can't think of anything else. We looked at rational functions. We looked at rational inequalities. Let's talk about the factor theorem. Yes, please.
So for the final answer, could I also write as negative third x cubed x minus 4?
Say it again? You want to distribute. We have to distribute on negative 1/3. If that was the question, yes, we have to distribute. The polynomial has to be given fully expanded. Yeah. Good. So let's also look at the factor theorem. Let's say we have 10x to the 4th minus 3x squared minus 1 divided by x plus 1. We have a polynomial at the top. We have a polynomial in the denominator. We will be asked to use this long division to find the quotient maybe. But what I'm interested in is, given this, is x plus 1 a factor of, I'm going to call this one this, P of x. Is x plus 1 a factor of the numerator? What do I have to do?
Put x equal to minus 1 in the equation.
Very good. In the polynomial, very good. So replace x by negative 1 in the polynomial. If I get 0, what do I conclude?
It's a factor.
Good. What if I don't get 0?
That's
It's not. Very good. Awesome. So P of negative 1 will be 10 times negative 1 to the 4th minus 3 times negative 1 and minus 1. Negative 1 squared, of course. So this will be 10 minus 3 minus 1. You don't even have to calculate. Does not equal 0. What do we conclude about x plus 1? Is x plus 1 a factor of the numerator?
No.
It's not. Very good. So we know odd even, we know how to establish whether it's a factor, we know how to construct polynomials, we know how to graph polynomial and rational functions, we know how to find inverses. What about, let's say I have this graph. This is a function f of x, I hope you agree. And I would like us to graph f of twice x. So we're given a graph. So this is at -4, -2. This is at -2, 0, 0, 2, 2, 2, and 4, 0. So we're asked to graph f of twice x. What are we going to do? How do I determine the graph of f of twice x? Now I have to remember, is it this? Obviously it's a horizontal transformation. Or is it this? Exactly, by a factor of 1 over 2. So this x value, let me use a different color. So this x value is at -4. Where will it go? This x value is at -2. Where will it go? This x value is at 0 for x. Where will it go? This x value is at 2 for x. Where will it go? This x value is at 4 for x. Where will it go? Excellent. This is f of twice x.
So when we're shrinking the structure, just by the x value?
It depends. This changes x. But if we're talking about changing y, it's a different situation. Yes. Any questions on this? Yes,
If
Imran?
the 2 is outside the
It's a different story. Let's also do that. So we have the same function. Let's copy it again. The same thing, same points. And this is our function f. But now we want twice f of x. This transformation does not have anything to do with x. All x's x stay the same, but the y value for each x will change. So this is at the height of -2. Where will it go? At -4 indeed. This is at the height of 0. Where will it go? This is at the height of 2. Where will it go? This is at a height of 2. Where will it go? This is at a height of 0. Where will it go? This is the graph of twice f of x. Yes, please, baby. Yes. You can also print this out or download it and put it on your flash drive or computer, whatever you want. Okay. Is there anything that you would say, I'm not so sure, or I want to see another one, or just from anything?
Is long division going to be on?
Yes. Not the synthetic division. I don't know why, but they said no.
So for long division, how do you want to set up? Like every time I want to.
Very good question. So when we divide, let's say p of x divided by x plus 1, I want a quotient plus a remainder over x plus 1. Now this could be, if the remainder is -5, this could be -5. So it doesn't have to be plus. But quotient plus remainder over divisor. Now no one needs to tell you whether the division is, the process gave you a correct answer or not, right? You will always do this if you want to. X plus 1 times the quotient plus the remainder has to give us p of x, right? Well, that will always be the case. Good. So we have roughly about 10 minutes. So let's tell me what you would like to go back to in those 10 minutes. Yes, please.
I have a question.
Yes. Okay, 2 pence of yes. Okay, so the same time this is the greatest possible influence area given. So 2 pence, same size, 300 feet. Okay. So here's a word problem. So we have a, let's say a garden, we have 300 feet of fencing, and we want to determine the width and the length so that we maximize the area. So we bought 300 feet of fencing. We want to use it all, of course, and we want to determine the maximum possible. So determine x and y, the width and the length, so that this entire area is as max as possible, as large as possible. So we know that we have x plus x plus x, and we have y and y. So 3x plus 2y must equal 300 feet. Do we agree with that?
Can you repeat this?
Yes. So I put fencing here, here, and here. So I have 3x. And I put fencing here, y, and another y. So I have plus 2y. The perimeter of the whole thing is 3x plus 2y equals 300. Good. So now the area, we know it's x times y. Would you agree with that? Okay. So we're asked to find the maximum. Find the length and the width so that the area is maximum. Remember what we did before? These are two variables. We don't know how to handle two variables in a problem, but that's why this relationship is given to us, to eliminate one of them. And I always prefer eliminating y. So we'll solve this equation for y. So this is 2y equals negative 3x plus 300. And when we divide by 2, we get negative 3/2 x plus 150. Is that okay? Are you feeling okay? Are you okay? Can I help?
Okay, I'm good.
Tell me if I can help.
Okay.
Okay, so now we have an expression for y, and we'll replace y in here and distribute x. What type of function do you expect to get? Yes, so it's negative 3/2 x squared plus 150x. So we multiply this by x. Negative 3/2 x plus 150x. Quadratic. I'm asked to find its maximum. What do I need to determine? The only thing that gives us the maximum of a quadratic function. Very good. So we have to find the vertex. How do I find the x-coordinate of the vertex? Very good. Negative b over 2a, negative b, 150. 2 times a is negative 3. So then the answer is 50. Measurement unit, feet. And this is the x, which is the width. I can immediately go back and determine the y. The y meaning the length of the garden. Not this. This will be a different y. This y is the function value at 50. But here, this little y is the length. So so y equals negative 3/2 times 50 plus 150. This is 25, negative 75, so y equals 75. So the garden is 50 by 75 feet with length. Now I also want to determine the maximum. I just have to multiply these two. Yes?
So this is going to be the same. So where did you get this question from? Where is it?
Where was I?
Website?
So now when we multiply, we get 0, 5 times 5, 5, and 2, 35, 37. So we will say as the correct answer and full answer is this. Using 300 feet of fencing and dividing the garden like in the figure, the maximum possible area is 3,750 square feet. The dimensions that give the maximum area of 3,750 square feet are width 50, length 75. So this is in square feet. So please on the test, please remember to put measurement units at all times. Any questions? Yes, please, David, go ahead.
So, glad I guess I'm not gonna say that.
It's okay, that's fine.
Why isn't the British just 50, is 75? Is that section
Because
or
these
why?
are two different y values. This little y is the length of the garden.
Yeah.
This is the function value for this.
So that's the area,
Yes.
so,
So when you plug in 50 in there, you're gonna get 3752.
so you basically, okay.
But since I know that the area is determined with x times y, I multiplied it here and put it in there instead of plugging it in, but you can plug it in. So if you want to write, you can write a of 50, which is negative 3/2 times 50 squared plus 150 times 50. And it's guaranteed that you get the exact same answer. So in y equals, we have negative 1.5 times 50 squared, and then plus 150 times 50. The answer must be 3750 unless I made an error when I multiplied 75 by 50. Yes, please.
So when you go back to the equation, how did you jump from y to a of x? That's not what you did.
Which one?
The previous page, at the bottom of the previous page. How did you get from y to negative 3 and then adding another x?
I multiply by x. The area is x times y.
She plugged that y on the right side
Yeah.
into the y, so there's no
So
more
then
y.
it will be y over.
It's multiplied.
A equals x times